everyone. Riley and I are here today to share with you an experiment where we're going to be creating a chemical reaction and we're going to be collecting the gas that's created over water. So a few of the things that we're going to be using today. First is magnesium metal. It is a highly reactive flexible metal in ribbon form. We're also going to be using hydrochloric acid. This is 2 molar hydrochloric acid, and in today's reaction, it's going to be the excess reactant. So the amount of gas is going to be solely dependent upon the amount of magnesium used. So a few things about the materials that we're using. You guys are already familiar with a balance thermometer. The thermometer is going to be used to measure the water temperature, which has been sitting out for a while, so that water is equal to the temperature of the air and therefore assumes to be the same temperature as the gas that we will collect. Distilled water. And then a piece of equipment that you're not familiar with is this. This is called a gas eudiometer tube. You'll notice that at one end it's closed and at the other end it's open. You'll also notice that there are numbers along the side of the eudiometer tube that are similar to a graduated cylinder. So in the experiment today, it's going to be inverted like this, so it's closed at the top. A gas will be produced and we'll collect here at the top of the eudiometer tube, and then we can use the numbers that are on the tube to measure the amount of gas that's collected, okay? Now when that gas is collected, it's going to displace or push water out the bottom of the tube, okay? And then you'll also notice that we have a really large graduated cylinder here. This graduated cylinder is not used to measure anything, but just to provide the water necessary for gas collection over water, okay? So the first thing we're going to do is I already cut a piece of magnesium ribbon. And so this piece of magnesium ribbon is going to be folded around this piece of string. So I'm going to do that really carefully, and then I'm going to hand it over to Riley. So the reason for folding the magnesium ribbon around this piece of string is to delay the magnesium and the hydrochloric acid from coming into contact with each other. So you'll understand that in just a second. So Riley, would you hold that? Thank you. Next, we're going to go over here by the sink, and we are going to add about 20 milliliters of the 2 molar hydrochloric acid to this eudiometer tube. Okay? So again, in today's reaction, the hydrochloric acid is our excess reactant. So the amount that I'm adding here is not particularly important. We just want to make sure that we add enough for the reaction to complete itself. But after that, we'll have plenty of hydrochloric acid left over. So we have about this much hydrochloric acid. And then I'm going to fill the rest of the eudiometer tube with distilled water. So hydrochloric acid is more dense than water, and so the hydrochloric acid is going to remain down here at the bottom of the tube, and the hydrochloric acid is going to layer on top of that. So this is going to take just a second. How are we doing, Riley?
Good.
Doing good? Just a little bit more. Almost there. Uh-oh, did that fall off the string? Can you put that back on the string?
Yep.
Almost there. It's like watching paint dry. All right, so we want to fill the eudiometer tube all the way up to the tippy top, which it is. And then Riley is going to put the magnesium right there in that liquid. And I'm going to put this one hole stopper, it has a hole in it, right here. So that string is actually going to hold the hydrochloric acid, the magnesium here, so that it does not come into immediate contact with the hydrochloric acid down here. And then what we're going to do, you'll notice that the tube is completely full of fluid, so there's no gas present at all. And then we're going to take this and we're going to flip it over inside this water. Now the hydrochloric acid at this point is real kind of shimmery. And as it falls, remember, because it's more dense than water, we can actually watch the hydrochloric acid as it goes down to the bottom of the tube. And once it comes into contact with the magnesium ribbon down there at the bottom, the chemical reaction will start. So we know that when magnesium and hydrochloric acid react with one another, it's a single replacement reaction that creates hydrogen gas. the magnesium chloride ends up dissolved in solution at the end. But as the hydrogen gas is created, you'll notice that there is a tiny little amount of bubbles that are starting. As the hydrogen gas is created, it's going to go up to the top of the tube and take the place of water. That's why this is called water displacement. It's going to push water out the hole in the one-hole stopper at the bottom. And then when the reaction is completed, then we will be able to measure the amount of gas that was collected.
Kind of starting.
Is it starting?
Tiny little bubbles.
Tiny little bubbles. Lots of bubbles, yep. So that's hydrogen gas, a highly explosive gas being collected up here at the top of the tube. Isn't that kind of pretty? So if you look up here at the top of the tube, you'll notice that at the top of the tube there's a bubble of gas starting to collect up here. And since there's gas here, that means that some water must have been pushed out of the one-hole stopper at the bottom of the eudiometer tube.
Big bubbles.
Big bubbles, huh? It's really rapidly reacting down there. All right, it's getting close to being done. So now, in terms of how we know about the gas inside the tube, first of all, I measured that piece of magnesium ribbon, and the mass of that piece of magnesium ribbon was 0.025 grams, okay? I've measured the temperature of the water, which is 18.0 degrees Celsius. I've looked up the atmospheric pressure today, which will be on the slide when we continue in our video today. And now we need to talk about gas volume. So the gas volume can be read off the side of the eudiometer tube, but we always have to make sure that the water level inside the tube and outside the tube are equal, because it's only at that point that the pressure of the gas inside and outside are equal. So when the pressure inside and outside are equal, the volume of the gas that we've created is 28.30 milliliters of gas, okay? And we know the pressure of the gas inside because the pressure of the hydrogen gas plus the water vapor that forms inside the tube is going to be equal with the atmospheric pressure because the water level inside and outside are equal. So what we are going to do when we continue with our video today is to figure out how much hydrogen gas was formed and compare it against how much should have been formed so that we can figure out our percent yield.